Pulse width modulation is a method of voltage control that today is used quite extensively. PWM signals are for the most part used to control motors and pulse power supply units. This purpose is served by a number of control circuits, transistors, special microcircuitry, digital signal processors. As a rule, a transistor, often an FET, is used to control the generated PWM signal. Widely popular are the width pulse circuits that control powerful field effect transistors, MOSFETs. These transistors are capable of switching high current of up to 100 amperes and above at the gate voltage of 12 to 15 volts. The on-state transistor resistance is very low, which decreases the dissipated power. Control circuits are supposed to provide for at least 12 volt to 15 volt difference between the gate and the source. In some cases, PWM-controllers employ microchips with output voltage buildup of up to 25 to 30 volts at 8 to 14 volt supply voltage, which facilitates connection of the transistor in the circuit with the common drain. For the majority of loads with current consumption of below 10 amperes, and the circuits do not have an additional voltage buildup unit. Let's look at an example of PWM controller using a simple circuit based on the logical CMOS microchip inverters. The device is a square wave generator based on two logical components, where the diode separately changes the electric charge time constant and the electrodischarge time constant of the capacitor that sets the frequency. It is this property that enables changing the output pulse ratio and the value of the output voltage on the load. The circuit uses an inverting CMOS component K56YLN2, a field effect transistor that should better be applied with peak current, since it has a lower on-state resistance. This helps decrease the dissipated power and use a cooler with a similar footnote. The main benefit of this circuit is the simplicity of the structure and reliability of operation.